Good afternoon, student.
Good afternoon, sir.
Good afternoon. Today, to perform, we actually doing the experiment number two. We are not actually performing because it is in online class. So we have to actually see how to do that. The experiment number two, to find the critical resistance and the critical speed and OCC of DC shunt generator. How to do that? Yeah, just doing that. Okay. So this is experiment number two. Okay. this is actually our experiment title, to find the critical resistance and critical speed on OCC of DC generator. First, tell me the equation of generated EMF. First, tell me what is the expression of EG.
NP 5 Z by S.
N P 5 N J by 60 A. This is the equation of generated EMF. And when the machine is designed, the value of P, Z and 60A should be a constant. So you can write EG is equal to constant phi n. Write constant phi n. So if we plot, or if we have to plot OCC, what should we do? Tell me. If we make speed constant, what we can write now? If n is constant, what we can write? What we can write if we make speed constant? What we write?
A5.
Eg is equal to k dash 5. Can we write that?
Yes.
Eg is equal to k dash into 5. So if we plot, if we try to plot between First draw open circuit. Suppose this is a generator. First, for simplicity, we consider not shunt generator. Tell me which kind of this generator is. Then suppose if I giving a rotation, say denoted by n, we are providing a constant speed. Now tell me which kind of generator this is. Which kind of generator this is? Manish, tell me which kind of generator this is.
Separately excited.
Separately excited. First, we do experiment on that type. Then we see how to do on shunt generator. And the basic difference between separately excited generator and shunt generator are, in case of shunt generator, the voltage induced on armature is giving the supply to the field. But in case of separately excited, we are done it by a separate voltage source. So this is Vf. By a separate voltage source, we are giving the supply, and in case of shunt generator, the voltage is supplied to the field by its own, and we have to plot the OCC, and if we plot OCC, in case of OCC, what we plot in x-axis? What do we actually plot in x-axis? Deepak, tell me, what do we plot in x-axis?
Currents.
current? Which current?
Yes, sir.
Which one?
Yes, sir.
IF. What is the name of that?
Field current.
Field current. And in y-axis, why we plot?
EG, sir, generated voltage.
Generated voltage. And EG is getting at the terminal actually, though the circuit is open, though the armature circuit is open, so we can say that this is open circuit characteristics. Though the armature circuit is open, we can say this is open circuit. To plot OCC, we have a give a condition. What is the condition? To plot OCC, we have to make a condition. We have made a condition. What is the condition? Tell me. Because to plot OCC, we have to maintain a condition. What is that condition? Manish, can you tell me what is the condition we have to maintain by which we can plot OCC?
No, sir.
Um, you can see here, I write that condition is, I already write there, this is the condition. What is that?
IF equals to 0, sir.
No, I marked that. What is the condition?
Number of revolution is constant.
That means speed or speed of the armature should be constant. So by making the speed is constant, we have to plot the OCC curve. And what is the nature of OCC curve? It will plot is like that. We have seen when we actually in a video we see that there is a machine is rotating and we are performing the OCC curve test. Then from that we get the data, and after plotting this data we can see the nature of the graph is like that. So before we going to the video, first we have to know what is critical resistance. Tell me what is critical resistance first. Do you know what is critical resistance?
So it is the resistor at which the terminal voltage is.
It is the resistor Then
maximum field circuit resistance,
first Monish tell, then Deepak will try. First Monish, tell me what is critical resistance?
sir, at which the terminal voltage is equals to the generated voltage.
Deepak, tell me what is critical resistance?
Maximum field circuit resistance.
Mhm. Then what will happen at that resistance? What will happen at that resistance? Is there is voltage produced on armature or not? Deepak, if we increase the resistance of field path above the critical resistance, is there any voltage buildup?
No, sir. At a critical temperature, the voltage is also maximum.
Critical temperature.
Sorry, sir. Critical resistance.
At critical resistance, the voltage is near to residual magnetism voltage.
Yes, sir.
So there is no voltage buildup in armature due to the critical resistance. And I have said before that this is the value of field path resistance due to which there is no voltage buildup in armature. It's called the critical resistance. And how actually we get that? How actually we get that from the OCC curve? It's like that. Suppose we make this is field resistance curve, and uh, actually after getting the OCC we have to make a slope like that, and from that slope actually we get the resistance, and the field resistance curve or critical field resistance curve is passing like that to the OCC, and after calculating this resistance we get the critical resistance. And what is actually critical speed? What is actually critical speed? Do you know that? What is actually critical speed? What is actually critical speed? Do you know? Have you heard about critical speed? What is critical speed? Do you know? Manish, Deepak, Khushbu, Askar, do you know? Ayush, have you heard critical speed? Ayush, have you ever heard about the critical speed?
The last class में बताया था.
What is critical speed?
सर डेफिनेशन तो आप नहीं लिखवाए सर इसका. खाली आप हेडिंग दिए थे उसको.
First, we have to know what is critical speed. Vg is equal to constant phi. Get that one, and now we have to study what is actually speed. And it is denoted by critical speed. Is denoted by NC. And this is basically a speed of armature below which there is no voltage build up on armature. It's called critical speed. This is basically a speed below which there is no voltage build up in armature is called critical speed. And suppose I make a graph. Suppose in suppose in different speed we have done this OCC. We are plotting OCC in different speed. Suppose this is N1 speed, this is N2 speed, and that one is N3 speed. And what is the terminal voltage of in case of N1? What is the terminal voltage point? That is operating point. Which one is operating point? This is the operating point in case of N1, and the terminal voltage at that point is the terminal voltage. In case of N2, what is the terminal voltage? That means the crossing voltage of RF and OCC. The red color curve is of RF, and the speed at N2 we make a OCC on that point, and this is the terminal voltage. You can say this is the terminal voltage at that point. And in case of N3, what is the terminal voltage? And the voltage is produced in armature. What is that? What is that? And how much? We have marked 3 point in the graph. You can easily see in case of N1 how much voltage is produced on the terminal, that much. In case of N2 how much voltage is produced, that much. And in case of N3 how much voltage is produced, suppose this is V1, this is V2, and this is V3. Now tell me what is the terminal voltage in three cases. When the speed of that machine is N1, how much voltage is there? Tell me how much voltage is there?
B1,
V1. And when the speed is N2, how much voltage is produced?
B2, sir.
How much? V2. And when the voltage is, sorry, when the speed is N3, then how much voltage is produced there?
B3,
V3. Then tell me, in which case the voltage is not built up? In which speed? In which speed we can say there is no voltage built up in armature?
N3,
N3. That means we can say that this is the actual speed below which there is no voltage build up. If we draw another OCC curve below of that speed, you can easily say that suppose this is another curve and the speed at that time is N4. You can easily see that there is no voltage build up below the N3 speed. So we can say N3 is critical speed. And what is the definition of the critical speed? This is the speed, or you can say the speed of armature below which there is no voltage build up on armature is called critical speed. Just write down the definition. This is the speed of armature below which there is no voltage build up on armature is called critical speed. First we determine the critical resistance, then we determine the critical speed.
sir. Please repeat the definition, sir.
Uh, the definition of the critical speed is like that. Write down it, please. The speed of armature below which the speed of armature below which there is no voltage buildup in armature, is called critical speed. The speed of armature below which there is no voltage buildup in armature is called critical speed. Just
So
see
your
the
voice
video.
is not coming.
No, no, just see the video. What in that I'm explaining what I am doing. Actually, we are giving the mechanical supply to DC generator by an induction motor, and we are doing the connection of induction motor. Though there is three-phase induction motor, we have to supply three-phase supply to the induction motor, and by this wire or connecting this wire, we are doing the connection of induction motor, and we are supplying the electric supply to the induction motor. And that one which is in my hand is actually dual starter. We will studies later, and in machine 2 we actually studies that. And here we have to study only DC portion. So, and this is the right part, actually the right side of that panel is actually DC portion. And here you can see uh, the right one is actually here. In case of that two set, the left one is DC machine and the right one is induction mode. First, by induction motor, we are providing the mechanical energy to the DC generator, and these two are actually variable. This is variable resistance by which we can vary the resistance, and the symbol of the machine or motor DC motor is, so you can see on the panel. This is armature circuit, and the next one is field circuit, and we have to control the current of field circuit. So first making, we are making the field circuit. We are saying that this is a separately excited generator. First we taking the separately excited generator, then we see how to doing on shunt generator, because you can easily see or easily control the field current of separately excited DC generator. Then we see how we'll do it on shunt generator. Actually, first we are making the connection diagram. We have to make the armature circuit open. So we just adding a voltmeter. Tell me what is the internal voltage of voltmeter? Can you anyone tell me what is the internal voltage of voltmeter? because we have add or connect a voltmeter on armature circuit, and we also say that this is open circuit. Can anyone tell me what is the internal resistance of voltmeter? Can anyone tell me how much internal voltage, sorry, internal resistance should be in case of voltmeter, and what should be the internal resistance of an ammeter? Ayush,
नहीं पता सर, but
ideally the internal resistance of voltmeter is infinity, and in case of ammeter, ideally the internal resistance of ammeter should be zero. But in practical case, the internal resistance of voltmeter is high, or say you can say large, and in case of ammeter, the internal resistance is very low. If we connect the armature by voltmeter, you can say you have added large resistance. That means if the circuit behave like an open circuit, because if we uh, not connect two terminal, that means the resistance of that actually the resistance between that two terminal is high. So if we provide high resistance between any two terminal, you can say the terminal are as like open circuit. Actually, the circuit or the terminal are behaves like a open circuit. Have you got my point, Ayush? Why we are saying that the terminal is open, though we have connected voltmeter on that terminal?
so once again, sir, please repeat.
अब बोलिए वोल्टमीटर पे इंटरनल रेजिस्टेंस कितना है?
तो लार्ज होता है सर, बड़ा
लार्ज
होता है।
होता है। अगर दो टर्मिनल है मेरे पास और हम लार्ज रेजिस्टेंस प्रोवाइड किया, तो हम क्या बोल सकते हैं जो दो टर्मिनल ओपन है?
नहीं सर।
अच्छा, पहले बोलिए अगर दो टर्मिनल हम एयर में रख दिया, इफ टू टर्मिनल इन एयर, what is the resistance value between that two terminal?
इन्फिनिटी सर।
Infinity. And in practical, you can say this is very large resistance.
यस सर।
So if we provide a voltmeter on that two terminal, can we say that these two terminal are open?
ओ यस सर।
That's why in when we perform the OCC curve or open circuit characteristics curve, then we are just adding a voltmeter on that terminal. If we connect instead of voltmeter by an ammeter, what is the resistance between the two terminal? If we replace the voltmeter by a ammeter, what is the resistance of the two terminal?
सर जीरो।
Nearly zero.
स्मॉल।
That means that two terminal are behave like a short circuit. In any
यस
terminal,
सर।
if we add a voltmeter, these two terminal behaves like a open circuit, and if we add a ammeter in between two terminal, these two terminal behaves like a short circuit. Okay. Then moving forward, so you can see that we have connect the voltmeter on armature circuit, and we are actually changing the wire because we have to maintain such that there some extra wire should be in terminal. Otherwise, the terminal are got broken. So after that, we are giving the supply, actually AC supply, to rotate the induction motor. When we actually start the induction motor, and it provides the mechanical energy and the speed of corresponding at that time is 1492. Actually, we are giving the speed 1492 rpm, and you can easily see that there is no field current provided because the ammeter of the field path is 0, showing the reading of 0, and thus there is some voltage on armature. You can easily see that though there is no current in field path, but we get some voltage. What is the reason behind it? Why we actually getting the some voltage though there is field current is 0?
due to residue flux.
Due to the residual flux, and the voltage is called the voltage due to the residual magnetism. So when we start the separately excited DC generator, then we get a voltage which is due to the residual magnetism. Then after that, we have to increase the field current, and when we take the reading of any meter, we have to first calculate the smallest division. That means what is the reading of two indicator or indicating mark. Here the smallest division is 6 because in between 0 to 60 there is 10 mark. So we can say the smallest division, that means the value of voltage between two mark is 6. That is also called the smallest division. Now we are giving the field current supply, and in case of ammeter there is the smallest division is 0.02 because in between the current 0 and zero point 0.2 there are 10 division. So the smallest division is 0.02, and we are increasing the value of current is now 0.02, and we are getting nearly 48 voltage.
Sir, what is the speed of motor?
Actually the speed of that motor at that time is 1492 93. Suppose the speed is varying, is like 1492, 1493, and 1491. Is this variable speed or constant speed? What we consider that speed? The speed variation is 1 or 2 in the speed 1492. If we consider that is constant speed or variable speed?
Constant.
Constant speed. Good. Because to perform OCC we have to provide constant or variable speed.
Constant.
Constant speed. you can easily see if we increase the value of field current, then the voltage is produced more and the speed is 1493 nearly. And I also provide the data how much voltage and how much current is provided and how much voltage is produced and what is the speed at that time. This is called the nameplate. By this we can get the maximum voltage we can apply on field, or so you can say how much current is maximum, how maximum how much current is provide to the field. This is called nameplate, by which we can say how much voltage is applied or how much current is provided to the current, to the field, to the armature. All those data are written on that nameplate. So this is repetitive process. We are just increasing the value of field current and taking the reading of speed and taking what is the voltage at that time. Just see that. And
इससे वोल्टेज तो बहुत बढ़ रहा है लेकिन स्पीड नहीं बढ़ रहा।
बिकॉज उनको स्पीड तो बढ़ा नहीं रहा है, हम क्या कर रहे हैं कांस्टेंट स्पीड देके फील्ड करंट को वैरी करके कितना वोल्टेज प्रोड्यूसर है वही देख रहे हैं। क्योंकि ओसीसी में क्या करना है, प्लॉट किसके किसके साथ करना है प्लॉट को, बोलिए। व्हाट इज
स्पीड
ओसीसी?
के साथ और वोल्टेज के साथ सर।
इसके साथ
स्पीड के साथ सर।
फील्ड करंट को वैरी करके कितना वोल्टेज आ रहा है आर्मेचर में और वोल्टेज कितना प्रोड्यूस हो रहा है वही तो देखना है हमें। बाय मेकिंग स्पीड कांस्टेंट, you have to provide a constant speed and change the field current. After that you have to measure how much voltage is produced on armature, and after that you have to make a curve between the induced voltage of armature and the field current. That curve is called open circuit characteristics curve. This is voltmeter, this is ammeter, and what is the name of that meter by which we measure the speed? Can anyone tell me?
स्पीडोमीटर सर।
Tachometer. This is called tachometer. The speed is constant because the speed reading it in first time we what we say 1492 and it varies 149193 like that. So we can say we are providing a constant speed, and this is called variac, by which we change the resistance of that circuit so we can control the current of that circuit. And after complete the experiment, we have to do all the reverse process. That means at the starting time of the starting, the machine at that situation we have to return on that position. So now, okay, where it is. What we actually did in this experiment? Tell me, Manish.
सर स्पीड को कांस्टेंट रख के वोल्टेज और करंट को मेजर किया।
किसको वैरी किया? वैरी किसको किया?
सर करंट को वैरी किए सर।
करंट को वैरी किया। वो कौन सा करंट है? उसका नाम क्या है उस करंट का? What is the name of
फील्ड
that?
करंट सर।
Field current. And what is the name of that voltage which we actually measured by a voltmeter?
सर टर्मिनल वोल्टेज।
Terminal voltage, and you can see, or you can say at that time this is induced voltage, because
जनरेटेड वोल्टेज।
the terminal are open at that time, though the open
यस
circuit
सर।
characteristics is performing. So we can say the terminal voltage is equal to the induced voltage. So this is serial number. This is field current. This is generated voltage or generated EMF. What is the unit of generated voltage?
वोल्ट्स।
And what is the unit of current?
एम्पियर।
And first we taking the field current 0, At that time voltage is generated is 37 and the speed is 1492. Then the value of current is 0.02 and the voltage is 48 and the speed is 1492. We are increasing just field current. And all that reading are taken at the time of experiment. These are the reading actually we have taken at the time of experiment. Please go through the reading, and we have to make a graph, and your task is uh, to make a graph between the field current and generated EMF. And in the next class want to see that graph, and you have to calculate the value of critical resistance from that graph. Take the reading, and this reading also I can provide in Google Classroom. So from Google Classroom you also can take that reading. After that you have to draw the graph between generated EMF and field current. After plotting that graph, you have to, and the graph is like that graph. And after, if we plot that reading, we get it's like a red color graph. And after that we have to make a line like the green one, and from that green one we calculate the value of RC, that means critical resistance. You have to calculate that. Have you understand what you have done in this experiment, Manish? Manish, मनीष को समझ में आया क्या किया इस लैब में आज, क्या हुआ? आयुष,
Yes, sir.
तुम्हारा टास्क क्या है? What should you do?
So curve बनाना critical resistance निकालना.
वो ग्राफ ड्रा करना है और क्रिटिकल रेजिस्टेंस कितना है उसका वैल्यू निकालना है. So after that we continue. After getting the critical resistance, then we continue with that lab. So this is the today's class. Now I'm taking the attendance. Ayush Kumar,
Yes, sir.
Manish,
Present, sir.
Deepak,
Present, sir.
Rohit,
Yes, sir.
Asgar,
Yes, sir.
Khushbu.